Good morning, students. Today we are going to discuss topic of emission and absorption in the context of laser, right? Okay. According to Einstein quantum theory of radiation, the interaction of radiation with matter could be explained in terms of three basic processes: spontaneous emission, stimulated emission, and stimulated absorption. Okay, we will explain these terms one by one. Firstly, we will discuss about spontaneous emission. What is spontaneous emission? We know that atom exists in the higher energy state or excited state is only for 10 to the power minus 8 seconds. After that, atom returns to the ground state, that is E1, right? In this situation, when atom emits a photon of frequency nu such that this h nu, that is energy of this photon, that is equal to the energy difference between excited state and ground state. H nu is equal to E2 minus E1, where E2 is the energy level of excited energy state and E1 is the energy level of ground energy state, right? So this is regarding spontaneous emission. And spontaneous emission is exist in case of ordinary light, that is bulb, tube light, and all other lights except laser, which in which the phenomena of stimulated emission takes place, right? So next is Einstein coefficient of spontaneous emission. The probability of spontaneous emission, probability or probable rate, that is R21. The probability of spontaneous emission from energy state E2 to energy state E1 depends only on the properties of the energy state E2 and E1. According to Einstein, the probable rate of spontaneous emission, that is R21. Why we take 21? Because transition is from E2 energy state to E1 energy state. That is why we take R21. Spontaneous emission, that is equal to A21 N2, right? A21 N2, where here A21 is called Einstein coefficient of spontaneous emission and N2 is the number of atoms in excited energy state, that is E2, right? Okay, then next is the stimulated emission. So what is stimulated emission? This the basic phenomena of the laser is stimulated emission. That is why laser, full form of laser is light amplification by stimulated emission of radiations. So in stimulated emission, when an incident photon of energy h nu, that is equal to E2 minus E1, passes by an atom in excited state E2, it stimulates the atom in excited state to drop to the lower state. Or you can say, when an incident photon strikes on an atom in an excited state E2, then there is a transition of atom from excited state to ground state with the emission of photon along with the previous photon, right? Or you can say, when one photon strikes, there is emission of two photons along with the transition, right? So in this process, atom releases a photon of same energy, direction and phase as that of the photon passes nearby, right? So net effect is that a photon which stimulated the atom releases two photons when there is a transition from E2 to E1, or you can say when there is a transition from excited energy state to ground energy state E1, right? Okay, now next is Einstein coefficient of stimulated emission. Einstein coefficient of stimulated emission, the probability of stimulated emission from energy state E2 to E1 depends only on the energy density of the incident radiation and is given by R21 stimulated emission. R21 is, that is probable rate of stimulated emission, or we can say probability of stimulated emission. And why we take 21? Because there is a transition from energy state E2 to energy state E1. That's why we take R21. R21 stimulated emission, that is equal to B21 N2 rho nu. Here B21 is Einstein coefficient of stimulated emission and N2 is the number of atoms in energy state E2 or number of atoms in excited energy state, and rho nu is the energy density of incident radiation, this incident radiation, right? Okay, in this case, total probability of emission from energy state E2 to E1, or you can say from excited energy state E2 to ground energy state E1, is given by R21, that is equal to R21 spontaneous emission plus R21 stimulated emission. R21 spontaneous emission we had already done, and that is equal to A21 N2, right? And R21 stimulated emission is mentioned here in this equation, that is equal to B21 N2 rho nu. So put this value here. So total probability of emission or total probable rate of emission, that is equal to A21 N2 plus B21 N2 rho nu, right? And next is stimulated absorption, thought process. In case of stimulated absorption, when an incoming photon of light or photon of energy having energy h nu strikes on an atom which is in the ground state E1, after absorbing this energy from incident photon, the atom goes to the excited state E2, or you can say there is a transition from ground state to the excited state, or from E1 to E2 by absorbing this photon having energy h nu, right? So this complete process is called stimulated absorption. As the word indicated, stimulated means this photon stimulates the atom which is in the ground state, and absorption means this atom which is in the ground state absorbs this photon and goes to the excited state. That is why it is called stimulated absorption, right? So another is Einstein coefficient of stimulated absorption. The Einstein coefficient of emission, in order to find this Einstein coefficient, the probable rate of transition depends on the properties of energy states E1 and E2, and is given by the probable rate or probability is given by R12 stimulated absorption is equal to B12 N1 rho nu. Here B12 is Einstein coefficient of stimulated absorption, N1 is the number of atoms in energy state E1, or you can say N1 is the number of atoms in ground energy state or ground state, and rho nu is the energy density of incident radiation, right? So this is the probable rate R12 stimulated absorption, that is equal to B12 N1 rho nu. We take stimulated absorption as a subscript in this case if you want, right? Okay, then thank you very much. If you have any query, you can discuss with me. Thanks a lot.